Greetings, this is Stuart Sutton speaking, and today's screencast is a repeat performance and recording of a webinar I did earlier this week on using linked data for competency frameworks and competency schemes in the context of the CTDL and also in the context of the Credential Engine Registry metadata. Now, credential descriptions using CTDL are dependent on key areas on data created by partners and other third parties. That data includes concept schemes, classifications of vocabularies, including industries and occupations, industrial program types, etc. And also data describing competency frameworks in various flavors that express knowledge, skills, and abilities. So in sum, this screencast is about how this partner and third-party data is embodied in legacy forms and how that data can be mapped or machine encoded from those legacy forms into three languages of description of concern to the CTDL or to the Credential Engine. The first is the CTDL itself for credential descriptions and the descriptions of entities related to credentials such as organizations and so forth. The second, and this one is one that we'll be covering today as well as the one following, is the W3C Simple Knowledge Organization, or SKOS, S-K-O-S, which I've talked about a little bit before, for expressing control vocabularies in RDF so that they are amenable to linked data and you have utility on the open web. So one of the languages we're looking at today in relationship to legacy data is the W3C SKOS. The second one is the Achievement Standards Network Description Language, the ASMDL, for the description of competency frameworks. It too is based in Resource Description Framework, the W3C's Resource Description Framework, where resulting in descriptions of competencies that can be linked to and can be shared on the open web. So that's basically where we're going to be going. And here's the agenda on how we'll look at it. The focus is on the Credential Engine, descriptions in the Credential Engine, accessing existing third-party resource data stores. And we just briefly referenced those two types, concept schemes and competency frameworks, and their accompanying description language. And here are the two languages that I just spoke about briefly. The Simple Knowledge Organization System, SKOS, for describing concept schemes, control vocabularies, classifications, and then the Achievement Standards Network Description Language, ASN, for D2L. So what we'll do is we're going to look and build some understanding around both of those classes of resources, concept schemes, competency frameworks. Then we'll look at their accompanying vocabularies. We won't look at them in great depth, but we will look at them. We'll look at the similarity between the outcomes of those two vocabularies, the descriptions of those two classes, and things they share in common, their conceptual models. And then we'll kind of close by looking at some recipes for mapping and publishing the legacy data, the existing resource data held by third parties and partners as linked data. So the approach I want to take is to start first by looking at a couple of snippets from of CTDL data, very small snippets of CTDL data. One will start with concept schemes, and then we'll look at a competency framework. So we're going to look at how is a concept scheme expressed in CTDL, and how is a competency framework expressed in CTDL. Now, fundamental to the expressing of these external resources, competency frameworks, concept schemes, is a data structure, a thing, an entity, a resource in the CTDL that is used to describe and align the thing being described, like a credential, to some external node in a framework, such as a concept scheme or a competency framework. The object in CTDL is called the credential alignment object, and it is a subtype of the schema.org alignment object. So it shares what's provided by the schema.org alignment object, but it also adds a few properties that are, while probably not unique to the credential environment, are needed, and are particularly needed within the context of the CTDL. So here is a list of the properties that are used to describe the relationship between a credential and or a credential or a learning opportunity profile within the CTDL for describing a relationship between such things, credentials, learning opportunities, and some control vocabulary. The first three of these properties, we won't go into much detail. They're fairly straightforward. The alignment date, when was this alignment made? Alignment type, which allows us to identify the type. Coded notation, which is new to the credential alignment object, that allows us to record a notation where the vocabulary, the competency framework has a notation being somewhat like a classification scheme, like 3.1.1 and then 3.1.2, notation that is an abbreviation of an abbreviated identifier of of a node in the framework that is being described. So those the first three. The following two sets, the framework sets and the target sets, are what are key to us. The framework identifies the what I would call the container, or the competency framework as a whole, or the concept scheme as a whole. So the ONET occupations would be a framework, and then a single occupation within the ONET ontology would be a node within that framework. So this captures the framework, and the framework is an identifier to the actual framework, the framework name, and then a description of the node that's being mapped to. We'll look at examples here of how these work. So what you're looking at here is a snippet of JSON, and you'll notice the type line, credential alignment object. In other words, it's saying this thing is a credential alignment object, and it is describing an alignment between, for example, a credential and the ONET occupations. And the particular node in that framework is acute care nurses. So we get acute care nurses, and then we get the target node description, which is a description of acute care nurses. So that is data that is drawn from from ONET. Now, you can look at this and you go, well, that's pretty good. If I'm looking at a credential and I see, that it has a target occupation type. Note the occupation type in bold, that it has an occupation type of acute care nurses. It tells me a lot. It tells me a lot about that credential. But it doesn't tell us enough. And this is where some of the work that I'm going to be talking about a little further on, where the encoding into a machine form as RDF comes into play. Because what's really needed here are two additional pieces of information. One, we need framework URI, and what the framework the framework, the top one in red, is a URI that identifies the ONET occupation vocabulary. So that is identifying the vocabulary as a whole. And notice it's example ONET. So this is something I've made up. That URI is something I've made up. So the framework identifies the overall concept scheme, which is the ONET occupations. And then the one at the bottom, the target node is the identifier, the URI identifier for acute care nurses within the concept scheme ONET occupations. Now, you may look at these and you go, well, there's nothing unique about this either. It's quite likely that you can take a URL, a locator, and actually go out, link to that page, a page over in the ONET occupations. And that would be true. That would be true. If there is a URL, a uniform resource locator, that allows you to go to a page, this could link to a page. But what is really needed is not only the ability to link to a page, but to link to the data that describes the acute care nurses node in that framework. So while humans may like going out and reading and seeing the description of acute care nurses over on the ONET website, what an application, something like the Credential engine would like to do, is to be able to reach out and ingest the data that expresses the acute care nurses. So in other words, we said we're going to be looking at the thing called SCOS. We would like to reach out and ingest a SCOS description of acute care nurses that contains all of this data plus a lot more. In other words, it wants to ingest, it wants to be able to mash up that data, it wants to be able to bring that data into this description, display the pieces of it that wants to display, and perhaps uses some of it that it doesn't display for computational purposes. So it's a very different function. It is the return from the URI, the Uniform Resource Identifier, is the data, is actual data that a machine can understand. Whereas the HTML page that you might go out to, that you might link to, while great unto itself, does not serve the same function. So the function we're talking about when we talk about both of these languages of description, the ASN and SCOS, here we will be morphing into SCOS here with concept schemes, allow us to describe the concept scheme in structured form using the language SCOS, and for applications such as the Credential registry to reach out, get that data for acute care nurses and bring it back. Very, very powerful. Very, very powerful function. It also means that these URIs for both the concept scheme and this single node within the concept scheme are open identifiers on the web that people can link to, so that people can go, oh, my credential deals with acute care nurses, and their credential can have an occupation type vocabulary, and what they include as the value is this URI. So in other words, they link to this node within acute care nurses. What that means is that someone looking at this RDF encoded description of the ONET occupations, they would be able to look to pull up the URI for acute care nurses, the node at the bottom, the thing at the bottom here, and they would be able to query an RDF aware system about a linked data system, in essence, would be able to query and say, show me credentials that have been mapped to this node. Show me credentials that have been mapped to acute care nurses. And you can imagine that makes for a very, very, very powerful mechanism for exploring credentials and other resources directly off of the ONET vocabulary, because that transition has been made. Now we're going to look at another example here, but we don't need to go into that same level of detail because exactly the same thing applies. So right now we're looking at a concept description using within the CTDL. And now we want to look at a competency description using the CTDL. And you'll notice it also, notice that first line, at type credential alignment object, uses the same structure to express a competency that it did to express or a similar structure, I should say, to express credential competencies that it did with concepts. So here we see that we have a credential alignment object. Its type is competency. In other words, the thing described here is a competency. And the framework name is degree qualification profile. So this is going to be some node in the degree qualification profile. And here the target node description defines and explains the structure styles. Again, this is great. If you've got a credential and it says it requires this competency, you can point to it. It's there. Humans can read it. But we again want to go further. We want to go further. And the same two concepts apply. We want to take or have the folks at DQP translate, map out their wonderful content into these conceptual things. So here we have the degree qualification profile, and we have a conceptual entity from it, which is a competency, defines and explains the structure, etc., etc. And just as we saw with the concept scheme, the target node is a URI that identifies this concept within the degree qualification profile, and this concept that we see at the bottom, identified with that URI, is in the scheme degree qualification profile. So again, it functions exactly the same way. All of the power that we just discussed in terms of linked data around competency schemes is applicable here. So just a brief note before we jump into first concept scheme, the concept scheme language, SCOS, and then follow on with ASN. I just want to note that there is a huge movement. We always want movements to move faster than they do. But here we see a page from US data.gov. And if you're European, there's the United Kingdom and others in the European countries have corollaries to this. This is the open data government stuff. And you'll notice then the red is a set. So this is a set. What we see here in the graphic is a set of data stores, data sets that in fact have been encoded in RDF. In other words, they are linked data ready for the web. And what we're talking now about with our partners and third parties with these significant assets in terms of national data infrastructure, ONET, DQP, and so forth, to start thinking in the context of this even more powerful context of semantic metadata. And the little quote here that's been highlighted is dates back to 1995, and a commitment from data.gov that they were slowly going to move everything into semantic specifications for use on the semantic web. So it's all going this way. And the reason it's going this way is because the sum of these concept schemes and the sum of these competency frameworks in a linked data context is worth more than the individual components. Very powerful. So what I want to do now is I want to do two sections, starting with concept schemes and then move on to competency frameworks. So we'll start with competency schemes and using Simple Knowledge Organization System, or SKOS. Now, SKOS is a W3C standard, just like HTTP and other standards that we use for the web. It's a W3C standard for representing concept schemes, such as thesauri and classifications and subject headings and taxonomies, folksonomies, flat lists of concepts that don't have to be classifications or taxonomies. It's designed as a simple way of describing the kinds of concept schemes of interest to us. NAICS, the ONET occupations, SIP, the ESCO in Europe, the European Skills, Competence, Qualifications, and Occupations, which, by the way, are already in RDF and are already operational in the linked data environment, the European ESCO. So those are the kind of things, and I just repeated myself. The Simple Knowledge Organization System, SKOS, was developed by the W3C Semantic Web Deployment Working Group, and I believe it was deployed in 2009. It has caught on like wildfire on the open web, and in fact, it is the encoding mechanism now of choice of the Library of Congress, the British Library. You can go down a list of national libraries globally that are using SKOS because of this intrinsic power to link. If any of you have any of these thesauri that follow the ISO standard 25964, it has been mapped to SKOS. So if you've got something that was legacy that's even older that is and is ISO compliant, you're home free. Easy mapping from it directly into SKOS. So that's a little bit of history. The model. The model is really simple. It's a two-entity model. There is a thing called the concept scheme as a whole, and it's in the diagram on the left, that's the gray, and it's called a SKOS concept scheme. And it is the place where all of the concepts are in essence aggregated. So it is in some ways you can think of it as the document that contains the concepts for the concept scheme. So it's the container of concepts. The second entity in the model, and it's the only other entity in the model, is the concept. So these are the individual concepts of which the concept scheme is comprised, and each is declared as being in the scheme. So in the diagram here, we have two concepts. Each is declared as being SKOS in scheme. So they're both in that scheme. Notice they are not buried in the scheme. They are separate things. There's the scheme as a whole and its individual components, but they're separate, which means that any of these concepts could exist in more than one concept scheme. They are defined independent of the scheme and then are related to the scheme through the SKOS in scheme property. Now, other attributes. Now, why is that important? Well, it might be important down the road if we have organization A defines a concept scheme and it's got certain concepts in it, and organization B defines a concept scheme in the same functional area, and it wants to, in quotes, borrow concepts from organization A, it can do so. by simply including the concept from organization A's concept scheme into its own scheme. So they're separate, they're independent, and then linked together by means of properties. Here they're linked to the concept scheme through in scheme. You'll also notice that the concept scheme is linked to its top concept through a property called SCOS has top concept. And that concept has a narrower concept. So these entities exist in an RDF model, and their relationships are defined independently of the nodes themselves. So you can have any number of is narrower. So the top concept node could branch out. So you can imagine it's just branching out like a tree underneath. So it's very, very, again, very, very powerful. But it's a very simple model. Let's look at some of the properties that are there. These are the properties, and this is really almost all of the key properties in the SCOS specification, almost all of them. So in other words, it's small, it's compact. There are properties to express semantic relationships. There are properties to express documentary notes. There are properties to express the human readable labels of concepts and so forth. So the semantic relationships, there's broader and narrower. And we saw that in work here, where the center node has a concept that is narrower. So the center concept points and says, here is a narrower concept. So there's broader and narrower. In other words, this narrower concept, well, in fact it does, sorry. The narrower concept says it has a broader node and points to the broader node. So broader, narrower. Don't worry about broader transitive, narrow transitive. It's probably the most complex concept in SCOS. And it basically says, and if this doesn't make any sense to you, just let it go right over your head. Doesn't really matter. If we look at this diagram, we see that cats has broader mammals. So mammals can point to cats as narrower. Cats to mammals is broader. Mammals to animals is broader. In SCOS, however, you cannot infer that cats is broader than animals. Not allowed. If you want to do that, you have to declare it as transitive. So anyway, if that didn't make any sense, again, do not worry. Just let it go. So there's broader and narrower. There are associative relationships where you can say that one concept in your vocabulary is related, is associated to some other concept. You can draw that. We saw top concept in work. We saw here has top concept, and at the same time, that top concept can point back to the concept scheme with that it is a top concept in the scheme. We saw in scheme. Notations, again, are like classification notations 3.1.5, a notation that identifies a particular concept. And then labels. These are human readable labels. So every relationship has a human readable label, and you can have many human readable labels. You can have preferred labels in every language on the planet if you wanted to. So your concept could be expressed in French and German and Spanish and etc., etc. For preferred labels, the label you would prefer people to use. There's alt labels, which are labels that would refer you back to the preferred label. So alt labels might be variations in spelling and so forth. You can even have hidden labels so that you can include in your encoding common misspellings, so that a search engine can know what the common misspellings are of someone trying to search for this concept. So there's hidden labels. There are also conceptual labels in the form of images. You can even have images as your labels. So a bird could have an image of a bird, concept of a bird, an image of a bird. All kinds of scope notes to document what a concept is about. The scope note does the breadth or defines the scope of application or the domain of application of the concept, definitions, examples, history note on how the concept has changed over time, and so forth. It's very, very powerful, but very tiny vocabulary. There are also ways to map between concepts in different schemes. So I can say that I have a concept in my concept scheme that is a close match to a concept in your scheme. And using the URIs, that close match can be machine expressed. In other words, you can link to that. It isn't just the words close match. Since all of these are identified by URI, they are linkable. So you can map between nodes in concept schemes. So someone with a concept scheme of industrial classifications could map over to a different vocabulary and say ours is a close match to that concept over there. Very powerful. Here is a brief example, and you can see some SCOS up in the diagram, up in the upper right. This is a node from the United Kingdom's Archival Thesaurus, UCAT. And the concept here is economic cooperation. And if you look up in the corner, you'll see the label highlighted, economic cooperation. So that little node that economic cooperation hangs off of is the concept economic cooperation. So if you just walked around it clockwise, you could go, there's a preferred label, economic cooperation. There's an alternate level that has cooperation hyphenated. There is a scope note describing the scope of the concept. There is a narrower concept called economic integration, another narrower concept called European economic cooperation, another one in European industrial cooperation, and yet another one industrial cooperation. There is a related property, a related concept called interdependence. And every single one of these purplish nodes is identified by an identifier. That's how a URI, an HTTP-based URI. So all of these things are linked together into a fabric, even where it may be reaching across into someone else's vocabulary. And sometime looking at the PowerPoint, with a good cup of coffee or a glass of wine, you might just walk down what you're seeing on the left, the term, the broader terms, the narrower terms, the related terms, and look over here and see how they are tied together and expressed using SCOS. Here is another node from the UK Archival Thesaurus. Concept is Organization for European Economic Cooperation. That's the one here. Then you get two labels. You have the SCOS preferred label, and notice that organization is spelled with an S. Remember, this is the UK. Then there's a variant SCOS alt label, and it's spelled with a Z, and it drops the hyphen from cooperation. So you can infer kind of the one is British and the other is American, but they're different spellings and alt labels. The next block is really interesting. Other linked data sources. So this concept in the UK Archival Thesaurus of Organization for European Economic Cooperation has been linked out to these other data sets. The first one is the Virtual International Authority file, which is a linked structure, which I'll show you in a second, we'll go to it, where that links together all of the national all the major national authority files around the world. Very, very powerful. Links them all together. So I can go elsewhere and find out what other countries, how they have defined Organization for European Economic Cooperation. We'll look at those in a moment. Other types. Remember, this is a SCOS concept that we're looking at. The type of this thing is a SCOS concept. But there are other links that say, oh, it's also an organization in the DBpedia OWL representation. In the folk vocabulary, which probably doesn't mean anything to you, it could be an agent. This is an agent. This thing, this concept is an agent. Down at the bottom, it maps to the schema.org organization. So these cross mappings make it possible for you to extend the search, extend the exploration by simply following your nose, or having an application follow its nose, to these various other places. Let's take a look at, well, let me get past those. Let's take a look at the VIAF. So here's that same concept in the virtual international authority file. And you see the Organization of European Economic Cooperation has been mapped to this list over on the left of other national and international authority files around the world. So here you see the US, the concept in the US, mapping to Germany and so forth, and to all of these other languages. So in VIAF you might find alternate, a huge row of alternate languages expressing the same concept. But the neat thing is, if you think about that someone may have mapped a set of credentials, or more than one credential, to one of these nodes, you can automatically expand across to other nodes and see what has been mapped to those. So it's a wonderful way to expand searches and so forth. So it's very, very powerful. So anyway, so that's SCOS, and it's fairly straightforward, but also very powerful. So competency frameworks. I'm going to walk through competency frameworks in the same way, maybe a little faster, because there's not a great deal conceptually that's additional to capture. So instead of using SCOS, for competency frameworks, we're using the Achievement Standards Network, ASMDL, the description language based on ASN. Now, this language was developed by NSF, funding through from 1999 through 2013. And what it's intended to do is to consistently describe, or make it possible to consistently describe, any assertion of knowledge, skill, and ability. And it serves as a data representation of the canonical official competency framework. In other words, the competency framework exists out there, and what happens with ASN is all of the competencies within that competency framework are atomized, pulled out, and converted into data. So it serves as a data representation of that canonical version. Supports the semantic web and linked data processes through its basis in W3C's resource description framework. So that's just like SCOS. Supports cross-framework comparison and linking by means of the common abstract model. The common abstract model is RDF, and what this means is I can take a competency in one framework by organization A and map it to a competency in organization B's competency framework. So you can do cross framework mapping, and we'll see how that works in a bit. Supports design of profiles through what are called refinement and extension. RDF itself is inherently extensible. So what ASN does is it defines a set of properties, things you can say about competencies and competency frameworks, and yet it knows that people will need to add to it. So there are two ways to do that kind of refinement and extension. You can create subproperties and subclasses of those defined by ASN in your own profile of the ASN. So the Credential engine has its own profile of the ASN. So you can refine it by subclassing and making subproperties of existing stuff, or you can add new properties or classes where ASN falls short of saying something about a competency framework that you need to have set. So it's extensible. It also can express competencies at any arbitrary level of granularity. And by that I mean competency frameworks, though they're frequently graph structures, are expressed as hierarchies. And what this is saying is ASN doesn't care if your hierarchy of breaking a competency down, for example, breaking a competency down into a benchmark, into an example, it doesn't care how deep. It can handle any arbitrary level of granularity that the actual competency framework it's working with or trying to describe requires. So it is agnostic as to how deep. There are international profiles of the ASN already in existence. The U.S. AS profile has been used to develop what I call the ASMDL, which is the Desire to Learn repository, which is the largest repository of K-12 competency frameworks in the world. So it's been used in the U.S. It's been used in Canada. So there's a Canadian profile of the ASN, and there's an Australian profile of the ASN. And what we're going to be working with is what we're calling the Credential engine ASN profile. So we'll be working on our own profile of the ASN. So what ASMDL is not intended to do, and this is important, it is not intended to take the place of the canonical version of the competency framework. It is a data expression of the competency framework. As a result, it's not intended to support all the forms of narrative that may augment, enrich, or contextualize a canonical framework. For example, I have here on my desk a document called from the American Association for the Advancement of Science, AAAS, called Benchmarks for Science Literacy. Benchmarks for Science Literacy is 364 pages of narrative and weighs 2.3 pounds. It's huge. The actual competencies that all of those pages are discussing fill less than 20 pages of the document. In other words, the data only fills about 20 pages of the document. So the data representation we are needing to do the job does not include all of the richness of the original. So these data representations are not intended to supplant the canonical versions on which that data is abstracted. So here's the ASN model, and you might go, that's strikingly similar, strikingly familiar. It too is a two-entity model. Up in the far corner is a standard document. This is the complete framework as a whole, including provenance information and everything else. This, in a sense, is that container that is the thing that holds all of the competencies in the framework together. So in the ASN, that container entity is called the standards document. And don't get put off by the word standards. It's particularly a US term. Think about the Common Core state standards, and some people are offended by the use of the word standards. But anyway, ASN was born back in the U.S., and was tied to that to that verbiage. Anyway, the standards document, there's that entity, again, the container. And then there are atomic units, conceptual units, which are in essence individual assertions about knowledge, skill, or ability. And each of those is a separate entity. And just like back with the concept schemes in SCOS, they are related to the standards document, in which they are a part through here. The Dublin Cores is part of property, and they have something that is similar to the broader, narrower concept over there in SCOS of has child and is child of. So the architecture of this two-entity model is very, very similar to that of the that we saw with SCOS. Here's a listing of properties that are available in SCOS to describe those two entities. And down here in the right-hand corner, you can see there's standards document and statement, and a few of the other properties that you see listed here. There are properties like those that are in red that augment these connector properties, these object properties that form links, that include things like concept terms and skill embodied and proficiency level. So any of those concepts, as defined in the vocabulary, can be used to describe a statement. You can describe the skills embodied, any concept terms that are there, and proficiency level, and so forth. You can also align one node in a competency framework, in one competency framework, to a node in another competency framework. So you could assert that there is an exact alignment between a concept in my vocabulary and a competency in my vocabulary and a competency in your vocabulary. And it doesn't matter where on the open web your vocabulary is expressed or where mine is expressed. We can use the URIs of the two concept entities to link them together in a way that machines can traverse and can gather, can ingest data from the other end. So this is an array of the properties, and over on the right, you'll see some what I call collateral classes. I've said there's only two entities in the model. There are a few others that are designed to help with description of other resources that map to a competency, but the core entities are the statement and the standard. So competency to competency mapping, some of the properties that we just saw. You could have a competency framework A and competency framework B, each with its own statements, and be able to assert relationships between the two, exact matches, broad matches, and so forth. Now, competency schemes can be flat. They don't have to be hierarchies. The ASN does not dictate the structure of a competency framework. That's up to the people who design the competency framework. For example, the DQP. Those competencies and the way they're put together is up to the people who do DQP. The role of the ASN is to express it in a way that is loyal to what the authors did. But you can have here. This is a flat set of competency statements that don't form a hierarchy, and they're each is part of the standards document. I thought it might be useful to look at what is my distillation of the DQP competency framework. And what you're seeing is the at the top, if we begin to translate this into ASN, at the top we see a standards document, DPQ, the competency framework, that's it as a whole. Then there is a set of top level notions, top level concepts that I've labeled from glance reading their stuff as categories. So you get broad integrative knowledge, civic, global learning, intellectual skills, and so forth. That using the ASN has child has a set of statements below it that are of the type education level, which is peculiar to the DPQ of associate bachelor, and we can go on down the tree. So here we see, hanging off of the bachelor's degree, we see a set of knowledge skills areas, analytic, so forth. And then finally we get down to competencies. So this is just the Stewart-Sutton analysis of DPQ and the formal relationships in DPQ, ferreting out what I assume those statement labels might be so that each one of these associate, bachelor, and so forth is of a kind of education level statement, expresses education level, and so forth. And then at the bottom are the competencies themselves. Now, here is a take on what is called a taxon path. It would be taking one path down, and the path that it takes is DPQ to specialized knowledge, and then under specialized knowledge would be this same tree that we see under intellectual skills. Just imagine it under specialized knowledge, and the taxon path is that path down from the source down through the hierarchy to the leaf concepts. So it goes, well, we'll see, I'll show you. So starting up in the upper left, we have the DPQ. It has a child node, in other words, a statement that is of the category, has a statement label of category. The description of the node is special knowledge, and the comment here describes what special knowledge means. What's special? So and that statement is expressed as a URI, http example.dpq.org/sk1/. And that URI returns, in a way, that URI encompasses the description, the statement label, the comment, plus any other things you want to say about it, such as skills embodied and so forth, which probably aren't applicable to that node. But then it has a child, and the child under special knowledge is the level, and the level is associate. And those properties, and that is accomplished with two properties, the statement label, which was used above also, and the description. And that node expressed with URI is linked to a child node that is of the statement label of the type competency, and it has its description, which is in essence the body of the competency. So this is one taxon path, again, one drop down through this hierarchy to a specific competency. And throughout this diagram, I've used the ASN vocabulary to express the whole thing. So if you want to get a look at what this looks like, there is, and I think the link is on the next slide, the Achievement Standards Network powered by D2L is the US, is a US repository. And here we see a node from, we see the jurisdiction is Arkansas, so we're in the system and we're looking at diesel electric systems in the state of Arkansas. And here on the left are the top level nodes in that competency framework. And if we open up that competency framework, we can see, if we go down the left side, we can see it identifies tools and their usage in electric systems. And if we look on the right, that's that node expanded, although it's not, even here doesn't list everything that may have been mapped to that node in describing the node, but we see that its education level is 10, 11, 12. Subject is career education. Subject there does not mean topicality, but subject is career education. The description, the text, it happens to be in English, but it could be in many languages. And notice up at the top, it has a URI. So it can be uniquely identified over the web. And that node belongs to, is part of that big URI at the bottom. That's the document, or the standards document, which doesn't show in this display. So if you want to go there. Well, you can get there through this link. If you go to the Desire to Learn link, you can get there and just explore, just play around, just go through and look at the variety of things. There are between, I think it's around 2,500 frameworks, full frameworks in that repository. But you'll get a sense of how the ASN works. Now, we're coming close to the end. Common traits. Notice the two, ASN and SCOS. Basic, same structure with a two-entity model. You might go, well, then why are we using two? Why don't you just use one? It's because the vocabulary to describe a concept in a SCOS is a different set of vocabulary. It's a different set of verbs. We have to say different things about competency frameworks than we say about competency frameworks than we do about concept schemes. Different things have to be said. Their structure feels the same, but we say, so their vocabularies are different, so they each have their own vocabulary. So here we go. This is the end. Now, most partners and third parties of interest to the development of CTDL descriptions already have their data. So this is an illustration that shows at the top the type of data, and I'll talk a moment about what that means, the type of data that the partners have. That data might be concept schemes. It might be competency frameworks. And in fact, it might be data describing their credentials. And what this figure is doing is showing the steps that are necessary to take data that exists in existing form in the repositories of partners and third parties all across the country, supporting and defining resources in the credential environment. How do they take those resources? How do they take credentials that they already have and are well defined? How do they take competency frameworks that are well defined, already exist? And how do they take concept schemes that they've got, like the ONET occupations? How do you take that data and map it out to the CTDL, and not shown here, but how do you map it out to SCOS, your concept schemes, and how do you map out your competency frameworks so that they become linked data on the open web that can participate in this emerging environment that the CTDL is hoping to enable. Now, most data that is held by partners, third parties, technically falls into one of two camps. The data is either well structured or it's text. Now, by well structured, I mean it already exists in spreadsheets, CVS or Excel. It's expressed in XML. It is in data stores that have APIs in front of them so you can search the data store. Relational databases. So structured stuff is all of that has already been atomized and its component parts described as in a spreadsheet. Each row describes a thing, each column describes an attribute. Those attributes have been broken out. They may have been broken out and are being currently stored in a relational database or in an XML database. anyway, the structured side also needs to have its data mapped out. Now, I want to emphasize, we're not saying changed. We're not saying changed. All of the partners have ways that they have worked out that they express their data for their current uses. We're now talking about a new use. And all this will ever ask is that certain tasks be done that maps the original data to the CTDL, to SCOS, or to the ASN, depending on what kind of thing it is, so that it can, as you see at the bottom, be published on the open web. Now, if you want to read more about this structure, the link down at the bottom, the structure is a modified version of an image in the text linked data evolving the web into a global data space. It's about the book, which is, by the way, a free version on the web at that link, is 2010, so things have moved on since then, but these basic conceptualizations have not. So you have structured data, or you just have text. Now, what's that? Text can be PDF files, Word files, files where an embodiment of your competency framework, your credential, or your concept scheme is in PDF form. It's there. It is conceptually structured, but it isn't technically structured. So there are means also for helping people who have data that is not in databases, not in XML files, but in PDFs, in other words, to also make that transition. So in the end, everybody has their data mapped out into these description languages that can then be used within the context of CTDL. We'll be doing a series of webinars that will break down into these two columns of structured and text going forward. So we'll have webinars with real technical experts with boots on the ground in taking data from in-house to the open web, in-house into RDF and into semantic metadata. Experts that with boots on the ground that will break out into those of you that have structured data and those of you that have text, and how to move forward with the least effort necessary to get the task done. Because again, the goal is not to make anybody redo what they currently do. We're going to ask them to do something on top of what they currently do. So that's basically it. I guess I asked for questions, and I can't take any since I'm doing a screencast and not a webinar. But anyway, if you do have questions, you can post them to the Google Forums for the Credential engine, and that's it. Hope this helps. Hope it didn't confuse, and talk to you later.